Okay, so here they want us to find the points that are equivalent to what we have here, and so we're given three 150. So 150 is going to refer to the angle that's going to create. So here's where 150 is. So I go that direction 3 units. So one, two, three. Roughly, it's kind of arbitrary, but I'm just going to kind of put it right here. If my pen will work. So that's where this point ends up. And so now we have to figure out which ones are equivalent. And so I'll go through a couple of these. So the first one is equivalent because you're rotating 330 degrees. So you rotate 330 and you're looking towards, a little bit further, 330. So you're looking towards this, but since my R value is negative, you go in the opposite direction. Instead of going towards that angle, you go 180 degrees in the other direction. So I would end up right on top of the original point that I'm trying to figure out what I'm equivalent to. The next one says rotate 30 degrees. So I rotate and I'm looking at 30 degrees, but I go backwards three. So I end up over here. So you can see it's not equivalent, right? Let's see. Let's go down to this one down here because this one's going to be equivalent right here. So this one rotates negative 210 degrees. Well, 210 is right here, but you're going to go in the opposite direction. So instead of rotating to here, I'm actually going to rotate backwards to right here, right where the 150 mark is at. And then I go positive three, so I go in that direction towards that angle. Because right here, this is negative 210 degrees also, the same as where positive 150 is at. And so that's kind of how it works. So you just do your rotations, and if it's a negative angle, you have to go clockwise. And so the reason this one doesn't work is because of the negative with the R value, because I would rotate and I'd be at the right spot, but the problem is my R value is negative, so I would go backwards. And so that's why this one did not work, the one above. And so the next question is basically the same thing, except it's in radians. And so I'll do a couple of these, and then we'll look at those other questions you had. So this one, the rotation is pi over 3. So you rotate and you look at it, and then I go 4 spots in that direction. So I'm just going to estimate that it's about right there. Um, so then if you look at this one, I'm going to rotate negative 5 pi over 3. Well, positive 5 pi over 3 is right here. And so if I'm going to go in the negative direction, or in the negative direction clockwise, I'm going to rotate that 3/4 and then one more slot, except I'm going to go the other way. So 1/4, 2/4, 3/4, and then one more spot right here. So I end up right here, and then my R value is 4, so I would land right on top of that original point right there. Um, if you look at this one right here, I'd rotate negative 1/3. So 1/3 is 1, 2, 3 clicks this way. So I'm going to go 3 clicks the other way. 1, 2, 3. And so now I'm facing right here and I go positive 4. So I end up about right here. So you can see that point is not equivalent to the original point. Let's do one more. If you look at this one, I'm going to rotate 4/3 pi. So I'm going to rotate to 4/3 pi, which is right here. So I'm looking at 4/3 pi, but instead of going that direction, I go the opposite. I go 180 degrees the other direction, and I go 4 spots. And so I end up right there. So I end up that one's equivalent. So that was equivalent. That was equivalent. This one wasn't. And so, anyways, hopefully that kind of gives you an idea of what's taking place here. If you need some more examples, just let me know. But let's look at the other questions you sent. Now, the questions 7, 8, and 10, they're all basically the same. So you're trying to figure out where this passes through the pole. And so what you have to do is just let R equal 0 and then solve it. And we'll have to use our calculator. So on the first one, so we're going to have 0 equals 3 minus 7 times cosine of theta. And then what we'll do here is subtract 3 from both sides. And then we're going to have to divide by -7. And so the double negatives will become positive. And so now I'm going to have cosine of theta equals positive 3/7. And so I'm going to have to take the cosine inverse of this in a second. But just to recall, this is my x and my r value if you were to look on a graph. And so I'm roughly, there's two different spots I could actually be. I could be over 3, somewhere up here, and somewhere down here. So I'm actually going to have to get two answers for this because that x value right there is 3, and then the hypotenuse is 7, and hypotenuse is always going to be positive on these. So there's going to be two possible angles that will give us those values right there. So we'll go ahead and put this in the calculator. We're going to take the cosine inverse of 3 over 7, and that should give me that first angle right there. And then I'm going to have to figure out how to find out that other angle in just a second. So I'm going to grab my calculator and try to turn it on. Okay, so I got it working, and so I have it in here, cosine inverse of 3 over 7. Oh, yeah, I need to make sure I'm in degrees. Okay, I'm in degrees, so I'm good. And so I'm going to get about, I think it says round, what does it say? Round 1 decimal place. So that's going to put me at 64.6. So 64.6 is going to be my angle theta. So that's this angle right here. 64.6. So this other angle right here would be negative 64.6. Now, my my parameters are between 0 and 360. So what I'm going to have to do is add 360 degrees to this right here, and that should give me the angle within that parameters right there. So I'm going to add 360, and that will give me that secondary angle right there. So let me pull the calculator back up. So let's see, negative 64.6 and then plus 360 degrees. And that will swing me around to 295.4. So 295.4. And just to show this to you real quick in my calculator, what I did was I took the cosine of 295.4. So the cosine of 295.4, and it gave me, if you look right here, it gave me 0.4289, so on. And that's the ratio right there. See, that angle would give me that ratio of 3 over 7, because you can see in the calculator, I also put in 3 divided by 7, which is 0.428. It's slightly off because my angle was rounded, but you can see that it matches. So those two answers do work. And if I would put 64.6 in the calculator, cosine of that, I would get 3 over 7, or roughly that. Let me see, I'll pull it up real quick and show you. So if I do cosine of 64.6, that's also going to give me about 0.42, so on. So right there. Okay, so the next one is basically the same thing. So you're going to let r equal 0. So we're going to have 5 plus 4 times cosine of theta. And we need to solve for cosine, so we'll subtract 5 from both sides. And then we'll divide by 4. And so we end up with cosine of theta is equal to negative 5 over 4. Now remember, this is the x value over your r value. So this is actually impossible. So this one's going to be none. You're going to put none as your answer on this one. And the reason why is if you look on the unit circle, let me go to a unit circle real quick to show you this. So if you go to a unit circle, if you look, cosine starts out at 1, right? And as I rotate around here, then cosine goes to 0, and then cosine will go to negative 1, and then it goes back to 0, right? And it goes back to 1. So cosine, the for any angle, my answer, my ratio has to be somewhere between 1 and negative 1. It'll never be more than 1, and it'll never be less than negative 1. It's always got to be somewhere between those two numbers. And so if you try to put it in the calculator, it's going to give you an error. So if you try to take the cosine inverse of negative 5 over 4, pull that up. The calculator will actually give you an error on that. So cosine inverse of -5 divided by 4. And so error out of the domain. So that's why this one's going to come out as none. Okay, the number 10 here, we're going to go ahead and set this equal to 0 once again and solve. This time we're dealing with sine, but it's going to be done pretty much the same way. And so we'll start by subtracting by 4 on both sides. So we get -4 equals 9 times sine of theta. And then we're going to divide by 9, divide by 9. That cancels out. So we're going to end up with sine of theta equals -4 over 9. And sine's the same way as cosine. It has to be somewhere between -1 and +1. And this ratio is -4 over 9 is somewhere between -1 and +1. So there should be an answer for this. And actually, we'll have two answers. So sine is y over r. So what that tells me, if I want to kind of get an idea of what this is going to look like, my y value is going to be down here at -4, and my radius is 9, so it's probably looks something like over here and over here. So those right there would give me a y value of -4 right there. So those 2 points that I put on there, and then I have a radius of 9. So I should have an angle over here and an angle down here. And so when I put this in the calculator, it's actually going to give me this angle right here. That's the angle it's going to give me. So I need to take the sine inverse of -4 over 9, and that should give me my angle. So let's see. We're going to do sine inverse of -4 divided by 9. And so that gives me, let's see, I think it says, does it say round one decimal place? Okay. So -26.4. So that angle right there is -26.4. Now, once again, my parameters, though, are between 0 and 360. So what I'm going to do here is I'm going to start off by adding 360 degrees to this angle right here, and that should swing me around, and I should be in um, the proper parameters. So let's see. So I'm going to go ahead. I'm going to add 360 to that. And so I'm going to get 333.6. So that's one of my angles. Now I need this other angle right here, which goes from here to here. Okay. Well, if this angle right here is -26.4, then this angle right here, since it's going counterclockwise, is going to be +26.4. So I'm just talking about the part between the x-axis and my angle right here. So just this little sliver right here. And then a half of a rotation right here would be 180. So I'm going to add 180 plus 26.4, and that should give me that other angle right there. And so let's see, that's going to give us 200. See, so we're going to have the 0.4 and then 6, carry the 1 over to where I get 206.4 degrees. And that would be the other angle right here. All right, I hope that helps. And if you got some more questions before the exam, just let me know, and I'll be happy to help you out.